All right, factoring day one. Enjoy. In factoring the greatest common factor out, what we do is we see what each one divides by. So they all divide by 2. They all have an x to the first, and they each one have a y squared. So we'll factor out a 2xy squared. Then I divide each term by 2xy squared. So taking 8 divided by 2, I get a 4. I have an x to the fourth divided by x gives me x to the third. Y squared divided by y squared is gone. I take 6 divided by 2, I get plus 3. I have x to the third divided by x squared left over. Y to the third divided by y squared, or y. And then minus, the 2 divides out, x is gone. Y to the fourth divided by y squared is y squared. And that's all I do. So greatest common factor. The next one is kind of interesting. First term, second term, they both have an x minus 7, so I'm factoring out an x minus 7 from both. So when I factor an x minus 7 out of the first term, I'm left with 3x plus 4y. When I factor an x minus 7 out of the second term, I'm left with minus 1. And that's your answer. All right, so when I'm factoring with a is just 1, meaning I have an ax squared plus bx plus c. When that leading coefficient is 1, I do the shortcut, and I look for 2 numbers that multiply to negative 15 and add to negative 2. So 2 numbers that multiply to negative 15 and add to negative 2 are negative 5 and positive 3. Next one is similar. I need to find 2 numbers that multiply to negative 16 and add to 6. So this only works when that leading coefficient is a 1. So what 2 numbers multiply to negative 16 and add to 6? So that's going to be x plus 8, x minus 2. Positive 8, negative 2, multiply to negative 16 and add to 6. Now when a doesn't equal 1, that leading coefficient this time is a 3. That's where you do the x method, if you like that. And what goes at the top is 3. Oopsie. What number goes at the top? I multiply the 3 and the negative 1. And so that gives me negative 3. So I multiply those. That gives me the number at the top. And what number goes at the bottom is whatever is here. So negative 2. Let me get another color. Negative 2 goes here. Then I think of 2 numbers that multiply to negative 3 and add to negative 2. So those numbers are negative 3 and positive 1. And then that's when you rewrite that term. You rewrite that as 3x squared minus 3x plus 1x minus 1. So you bring in those 2 numbers here and replace the negative 2x. Then you factor by grouping. So out of the first 2, factor 3x out, and I'm left with x minus 1. Out of the next 2, factor out a 1, and I'm left with x minus 1. So now both of them have an x minus 1 term. So my answer ends up being x minus 1 times what remains, 3x on that one, what remains, plus 1. So that's factored completely. All right, so looking at the next one, 4 and negative 12, I'm putting negative 48 at the top. Negative 13 goes here. That's at the bottom. Those 2 multiply, goes at the top. So I need 2 numbers that multiply to negative 48 and add to negative 13. So that's negative 16 and positive 3. So I rewrite this then as 4x squared minus 16x plus 3x minus 12. Factor, so out of the first 2, I can factor 4x, and I'm left with x minus 4. Out of the next 2, factor out of 3, so I'm left with x minus 4. So this thing finishes by factoring to x minus 4 and x minus 4 times 4x plus 3. All right, difference of squares, meaning something squared minus something squared. Change colors here. So difference meaning subtract. So I need a subtraction sign in there with two square numbers. And so what that does, it factors to 2x plus 9 and 2x minus 9. So you take the factors of each of them, or take the square root of each. So this is 2x minus 9 and 2x plus 9. The last one gets a little more entertaining here. So this is something squared minus something squared. So the square root of 2x minus y squared is 2x minus y. So that goes at the start of each parentheses. And the square root of m squared is m. So this becomes a plus m and a minus m. And that's your answer. All right, so factor into perfect squares, meaning this is something, a quantity squared. So I'm going to think of this, and we can do the x method, or a lot of times what this is, let's look at this. So 9x squared is a perfect square, 25 is a perfect square. So more than likely, that leading term will be the square root of that. So it's a 3x and a 3x. And the square root of 25 is 5 and 5. So if you had the box method going on here, so we have a 3x, a 5, a 3x, a 5. This 3x times 3x gives me 9x squared. 3x times 5 is 15x. 3x times 5 is 15x. 5 times 5 is 25. I need it to add to negative 30, so I'm going to make both of those negatives. So this is quantity 3x minus 5 squared. Next one, same idea. X squared is a perfect square. 1's a perfect square. So let's see what happens. The square root of x squared is x and x. The square root of 1 is 1 and 1. So if I add the square thing again, this is x1, x1. So this is x squared. This is a 1x, 1x, and a 1. So this factors to, if I need to add to the negative 2, both of these need to be negatives. So this is x minus 1 quantity squared. All right, factoring sum and difference of squares. A cubed plus b cubed is, make sure you know this formula. So this is a plus b, and then a squared plus ab, a squared minus ab plus b squared. And those that know SOAP, S-O-A-P, S meaning the same sign, opposite here, always positive for that last term. So a cubed minus b cubed is a minus b. So that's the same sign as what's there. Then it's a squared plus ab for opposite, and then plus b squared at the end. But I have to determine when I have a cubed minus, or this is a cubed minus b cubed. So 64x cubed minus 1, I have to determine what is to the third. So 64x to the third is what to the third? You're going to think of that as 4x quantity to the third minus 1 to the third. So my a is 4x and my b is 1. So when I put that in the first parentheses, a minus b, so this becomes 4x minus 1 times a squared. So 4x quantity squared is 16x squared. I square both of them. Plus a times b. So my a is 4x, my b is 1. So 4x times 1 is 4x. Plus b squared is 1 squared is 1. And that's that one. All right, new color, red. 3y to the third minus 81 to the third. So the first thing looking at that one is I can see both of these divide by a 3. So I'm going to factor out that greatest common factor 3. So it's y to the third minus 81 divides by 3. I believe it's 27. X to the third. So then I look at this, what's in here, and leave that 3 alone outside. So this is 3. Leave the 3 on the outside, but I'm going to think of that as y to the third minus 3x to the third with a 3 on the outside. So my a is y, and my b is 3x. So finishing this out, I have a 3 on the outside. My a is y, my b is 3x, so this becomes y minus 3x, because that's a minus b. Then I have to square the a, so y squared plus multiply y times 3x, that's going to be a 3xy, and then always positive, so plus, take b and square it, so square both of those in there, you get 9x squared, and leave the 3 on the outside. All right, factoring completely. Looking at the first one, both of those divide by a 2 and an x squared, so I'm going to factor a 2x squared out of both of those. So if I factor a 2x squared out of that, I'm left with x squared. Factor 2x squared out of negative 8x squared minus 4 left over. We're not quite done. X squared minus 4 is the difference of squares, so you have 2x squared on the outside. Factor x squared minus 4 to x plus 2 and x minus 2. Looking at letter B, what do they both divide by? Both of them have an x, and both of them have a y squared, so put that on the outside. Reduce, or divide each out, so x to the 5th divided by x is x to the 4th. Y squared goes away. Minus the x divides out, and I'm left with y to the 4th. Still, that is a difference of squares, so I write xy squared. So x to the 4th minus y to the 4th would be x squared minus y squared, and x squared plus y squared. We're still not done. This is the difference of squares yet. So this becomes xy squared times x plus y, x minus y, and then x squared plus y squared. So this became that. So this whole thing is my final answer. Letter C looks a little confusing, but it's actually almost in factor form. So what can I factor out of the first two? It looks like x squared, and I'm left with x minus 3. Out of the last two, factor out a negative 4, so in my parentheses is x minus 3. Divide both of them by negative 4. So this then becomes x minus 3, they both have, and x squared minus 4. But again, x squared minus 4 is the difference of squares, so finish that out. So x minus 3 times x plus 2, x minus 2. And that is your final answer. All right, letter D. I'm going to go down here and start D. Put these over here. So letter D, I'm going to use chunking. I'm going to say let capital A, let's say, equal 2x minus y. So then that becomes a squared minus a 10a plus 25. So that's my a's. My a's are the 2x minus y. So then looking at this, my leading term is a 1a squared. So I can do this shortcut for factoring. So I'm going to put an a and an a here. So I need two numbers that multiply to 25 and add to negative 10. So minus 5 for that. They multiply to 25, and negative 5 adds to negative 10. But we're not done yet. I need to put the a back in there. So my a is 2x minus y. So this becomes 2x minus y for my a minus 5. And 2x minus y minus 5. Or we could make that nicer. So we could write that as 2x minus y minus 5 quantity squared. All right, letter E. On letter E, we could factor out a 2y squared from both. They both divide by 2y squared. So I'm left with y to the 4th minus, 16. So we finish this, so that's a 2y squared. Difference of squares. That's going to give me a y squared minus 4 and a y squared plus 4. Another difference of squares, so 2y squared, y plus 2, y minus 2, and y squared plus 4. So always when you see that difference of squares, finish it. All right, last one on this set, letter F. Both of those have a 4. They've been both divided by 4, so I'll put 4 on the outside. So that'll be leaving me with 4 minus x squared. Finish that, so I have 4. 4 minus x squared would factor to 2 plus x and 2 minus x. That was a nice way. That was not a terrible one to end on. So difference of squares is the biggie. All right, factoring with fractional exponents. Like we did when we had 2y to the 6th, 32y squared, I divided by, or I factored out the exponent, the smallest exponent. So we're going to do the same here. We're going to factor out the smallest exponent. And when I'm looking at 3 halves, 1 half, negative a half, my smallest exponent is x to the negative a half. And they all have a 3. So I'm going to factor out a 3x to the negative a half. So what that means is I'm dividing each of these terms by 3x to the negative a half. So when I divide, I see what's left over. So 3 divided by 3 is 1. And then I take 3 halves minus x to the negative a half. Or 3 halves minus negative half. So 3 halves minus negative 1 half would be actually 3 halves plus 1 half, which is 4 over 2 or 2. So this is an x squared left over. So I'm subtracting the exponents. Divide the numbers. Negative 9 divided by 3 is negative 3. X to the what? Let's see that one. So that's going to be 1 half minus negative 1 half. So 1 half minus negative 1 half is really 1 half plus 1 half. So I just end up with 1. So x to the first, I don't have to put a 1 there, plus 6 divided by 3 is 2. And those divide out. So I have x to the negative half, x to the negative half. That is gone. So then I'm left with here. So 3x to the negative a half on the outside. And then I finish factoring that. And now it's in the nice form of multiply. I need two numbers that multiply to 2, add to negative 3 because my leading coefficient is a 1. So that's going to give me x minus 2, x minus 1. Because negative 2 times negative 1 adds to negative 3 and multiplies to 2. All right, last one. Let's look at it. This one we're going to want to do a couple things. Let me change the colors again. Go green. So I'm going to take this one and let's write it over here. So first thing I want to do is I'm going to say let a equal 2 plus x. Let's make this a little more pleasant. So then this is a to the negative 2/3. So I'm replacing the 2 plus x times x plus x to the, or not x, 2 plus x is my a to the 1/3. Now I'm going to factor out the least exponent. So my smallest exponent is a to the negative 2/3 goes on the outside, which means I'm going to divide both of those by now a to the negative 2/3. So in the first one, when I divide by a to the negative 2/3, I'm left with x. Here, when I divide by a to the negative 2/3, so that's going to be a to the 1/3 minus, I'm just subtracting exponents, so I'm just going to do 1/3 minus negative 2/3. So that's 1/3 plus 2/3, which gives me 3/3 or 1. So this is a to the first power. Finish this out, my a to the negative 2/3. Make it look nicer, x minus a. Then we finish out what is a. A is 2 plus x. So I just replace that as 2 plus x to the negative 2/3 times x minus quantity 2 plus x, because my a is 2 plus x. So this becomes 2 plus x to the negative 2/3. X minus 2 minus x, distribute that negative. So 2 plus x to the negative 2/3 times negative 2. Let's make it look nicer. So put negative 2 on the outside times 2 plus x to the negative 2/3. That one is confusing. All right, that is it for the notes today.